Well, good afternoon, everyone. I think it's 4 o'clock, so we'll get started here. Well, we are so excited that you've joined us for the first class conference. My name is Dr. Rachna Tiwari, and I'm an associate professor here at UT Martin in agribusiness and agricultural economics. And I'm also the project director for CLASS, which stands for Climate Literacy for Agriculture and Sustainable Societies. So our teams at UT Martin and Murray State started CLASS a couple of years ago with the goal of enhancing educational outreach and research opportunities in the area of climate change, education, and agriculture. So this CLASS conference is a partnership between UT Martin and the Global Teach Ag Network at Penn State and Murray State University, and that's how we bring CLASS to you this summer. So starting today and for the next 2 days, CLASS is guided by a theme for each day of the conference, which is the first day we'll be talking about awareness, which is why is climate change education critical for student success? The second day, we'll focus on development, which is how can educators incorporate climate change education in their programs? And finally, the third day, we'll have a call for action that how can our students engage locally in global climate change education? So that's kind of the big theme of our conference here. And we'll just go over a few quick points for this introduction and some things for you to note real quick. All right, so we do have some information about RUA, which is the learning space. So please be sure to look at some of this information about the chat feature and then the attendees feature and the community thread and the documents. We'll continue to give you some information regarding it throughout for the conference, some activities and some events that we'll have. We'll also have, some opportunities for conversation through the community thread. So please be sure to look into that. Also, please keep muted when we are during the conference, and please use the raise hand feature to request to talk about preventing talking over each other. And any concerns, please direct message to Dr. Daniel Foster on Zoom, which is in VOA or via email at the email provided here. The cell phone is 814-753-2102. So the theme for today again is awareness, which is where we discuss the importance of climate change education for agriculture and rural communities. And we also describe some learning opportunities for Kentucky and Tennessee students in the science of climate change. So before we get into the actual event, I would just switch over for a minute and give it over to Dr. Daniel Foster to talk a little bit more about RUA.
Okay. Well, everybody, I hope that you're doing well. We're excited to be here with you, and I'm going to make sure that we're really clear why we're excited, because it's wonderful to work with scientists who believe, like we do, that educators are the key to the future, that teachers matter, that teacher can ensure that our students and communities and world can be successful. There's a very global influence to it. I asked for 2 minutes and I've already spent 30 seconds of it because I really wanted to make sure that we highlighted the platform we're using for everybody in the call. See, you're going to get great information today. We're going to have a lot of fun over the next 3 days, but we believe that perhaps the most powerful element is the opportunity to interact with our fellow educators, the community. And so we choose a platform very specifically to take off the reins where we're not running every conversation and give you opportunity to have voice and autonomy as the professional educators you are and engage in community. And so if you would humor me for a moment, I would like to share with you and talk through the Whova platform. So here is the home screen. And if you have any concerns or issues about accessing, my main man, Carson Latot, is ready on hand, and he's emailed and can reach out to you and help you as needed. But you have two ways. You can have the mobile app or the desktop app. Now, I download the mobile app. It's fun because I can keep conversations going when I'm having to walk the dog, take care of chores, and do everything else that's in our lives as we go through. But when I sit down to actually learn and focus, that's when I'm on the desktop app. And I'm going to really just highlight for you 2 or 3 spots that I think are winners. Number one, look who else is in here. Click on attendees like I just did, and you can roll down and see who else is involved. So I see that Audie's here from Webster County in Kentucky. I didn't even cross-check to see if he made it into this session. I hope he is. But I see that Arlie is, and I can see her picture and start checking out, and you can even talk to them directly. Because remember, Zoom chats go away, this provides a way for you to have conversations when someone drops that nugget of knowledge that you really want to follow up on. We'll learn best from our fellow educators. In fact, we may want to pose questions to everyone. And so if you click on community, I'm going to draw your attention to the fact that there are already some threads here where you could come in and comment or ask questions or follow up. We've asked our presenters to be aware of these spaces. Hopefully Stu will recognize that he has a thread here. So maybe if you have that question that comes after his off, he can look at that later and respond to it and answer, and everybody can see it instead of having to write the same email 15 times. But looky here, you can add a topic. So maybe you want to say, hey, I have sophomores and we're doing this, and how can we do this? You could pose a question to everybody and let them respond. So feel very comfortable and empowered to create those topics as you wish. And I only said 2 or 3, so I'm going to give the last one, and then I'm going to bounce out so we can get to the rest of the fun. If you'll look here, you'll see documents. And so when we identify documents that we're going to share, we can upload them there so that you can access them later. Now, the good thing about this space is that it doesn't close at the end of the conference on Thursday. It's going to be open for a month or 2, 3 months, actually, I think easily into your fall semester, so that you can come back to it, because sometimes, you know, we're like, hey, I need that. What was that they said? And we'll know where to find those resources. That's all I wanted to share for now. I'm going to go back to Dr. Tiwari. I believe maybe I'm going to Mark. I should have looked at my script closer, but I'm going to pull Dr. Tiwari back to the digital dais to speak to you. Thank you for letting me share, and we're excited to work with you and learn with you in the next 2.5, 3 days. Thank you.
Thank you, Dr. Foster. This is great information. Just a quick mention of something I would like to share with everybody before I introduce our the next person here. I just wanted to bring to your attention the educator kits. I hope you all received those in the mail that we sent out last week or the week before that, but hopefully everybody received it. So just a quick reminder that you will use some of the printed materials that came in with the kits in the workshop tomorrow. So please be sure to, refer to those. If not, we also have them as PDFs in the sessions in BUA. If you go for the session tomorrow, the agenda, and then you look through the session, you should also see the PDFs there, just in case if you're, looking for these again. And also, if you look through the photos tab in WUA, the one that just, Dr. Foster explained just now, if you just look through the photos tab on the left, there's also a fun contest that we put out there. So it's related to the educator kit. So please do check it out also when you get a chance this evening. And now I would like to invite my wonderful colleague and co-project director, Dr. Mark Simpson, who will guide us to the next event.
Yes, good afternoon, and I'm Dr. Mark Simpson, professor here at geography at the University of Tennessee at Martin. And I would like to introduce to you our first speaker and presenter, who is a good friend of mine and colleague of mine from my days at Western Kentucky University, Dr. Stuart Foster. Dr. Stuart Foster serves as a state climatologist in Kentucky and is director of the Kentucky Climate Center. He's a member of the Kentucky Drought Mitigation and Response Team, serves as co-chair of the Climate and Water Resource Data Team. Dr. Foster is also director of the Kentucky Mesonet, a research-grade network of automated stations and climate monitoring stations around the state of Kentucky. Something we try to get established here in Tennessee, and we're still working on that. Dr. Foster served as the president of the American Association of State Climatologists. His technical interests actually are in statistics and data visualization and analysis, and including the development and application of varying parameter models using tools for exploratory data, spatial data analysis. He started at Western in 1988, and he's a graduate of the Ohio State University, getting a PhD there in geography. He and I have known each other for a while, longer than we care to admit. And we started our discussions as over breakfast at the Garrett Conference Center, poring over Major League Baseball stats. And he's still an avid baseball fan. So I present to you, it's my honor to present to you my good friend and colleague, Dr. Stuart Foster. So take it away, Stuart.
Thank you, Mark. I greatly appreciate that. And I'm very happy to have the opportunity to spend a little bit of time with you all today. Okay, that sounds good. That sounds good. So the title I put together for the presentation today, Climate Change, Would You Recognize It If You Saw It? And I think that's a pretty fair question because while this is a topic that we hear about quite a bit, if somebody asks you to go out and look around and find some evidence that will convince someone that the climate's changing, that'd be pretty difficult to do. We'll tackle it from that perspective. And there's some evidence of climate changing just in terms of looking at the recently released climate normals update. These climate normals are a way of giving us an idea of what's typical or what's average for our climate. So when you hear the TV meteorologists say that the temperature was 3 degrees above normal today, well, that normal is by definition what the National Centers for Environmental Information indicate is an average for our area. And these are updated every 30 years. And so the new 1991 to 2020 climate normals were just released. And as you can see here, the average annual precipitation changed over the last decade across the country. And if you look at Kentucky and Tennessee, you can see that that's one of the areas in the country where there was the largest increase in average annual precipitation. And then likewise, if you look at temperature, our average annual temperatures have increased just a little bit there, about half a degree or so. And so the climate is changing, but would you expect it to stay the same anyway? Probably not. So there's some evidence that it's changing, but we want to look a little bit more deeply at that. And then here's an image of the current U.S. drought monitor. If you look at our region, we really don't have any drought concerns here in Kentucky or Tennessee at this time. But if you pay attention to the news and the weather across the country, you are probably quite aware that the drought conditions have become very extreme in the Southwest and also across the northern plains and upper part of the Midwest, where we're starting to see drought develop. And so when you look at that, you may start to contemplate, is this just a normal cycle, or does this reflect the notion that our climate is changing and these drought patterns may become more common going forward? So with that introduction, I will give you an overview of what we're going to do here in this presentation. I'll give you a brief overview of climate and climate change. I'm not going to get too much into the science of it, but we'll touch on it. And then want to talk about climate change as a wicked problem. So we'll have to get a notion of what do we mean by a wicked problem in the first place. And so once we've had that introduction, we'll take a few minutes for a breakout session and then come back and really delve into precipitation and temperature trends since 1985. Since I'm the state climatologist for Kentucky, the analysis will focus primarily on Kentucky, but as you might expect with Tennessee sharing a long border with Kentucky, you could expect some of the similar patterns and trends there also. And then we'll wrap up by focusing on climate extremes and the significance of those for us going forward before we pull things together with a summary. So I grabbed this image of the Earth and its atmosphere this morning just to provide some context. So, we sit down and see the world from sitting on our front porch, and sometimes it's helpful to kind of step back a little bit and take not a bird's eye view, but a satellite's eye view of the Earth. And you can see there in the image a representation of the Earth's atmosphere there around the globe. And you know, if you think about the Earth's atmosphere is, you know, it's much denser near the surface and becomes much more sparse as you go up in altitude. And it doesn't just stop at a certain point, but it's basically about 60 miles in thickness compared to the Earth's diameter of about 8,000 miles. So it's just a sliver, so to speak, in contrast to the Earth. And yet it plays an incredible role in terms of making life possible for us. Without the atmosphere, the Earth's temperature would be about 0 Fahrenheit, would be covered with ice. We would not be here. So it's very thin, but it creates a climate and environment in which we can survive and thrive. And yet within that atmosphere, we have this so-called greenhouse effect that's associated with certain gases that comprise the atmosphere, but they represent a very minuscule amount of the atmosphere. So it's really phenomenal what a small volume of gases can do in terms of making life possible. So this graphic coming from the National Climate Assessment kind of shows this idea that solar radiation comes in to the Earth's surface. It is, many things happen to it on its journey through. Some of it's reflected back out in space, some of it is absorbed in the atmosphere, much of it is absorbed at the Earth's surface or reflected back, and the energy that's absorbed at the Earth's surface then is re-radiated back out into the atmosphere and such. So the atmosphere effectively works like a blanket. You know, if you put a blanket on your bed at night and it helps keep you warm in the wintertime. So as we put more greenhouse gases into the atmosphere, carbon dioxide, the one that we hear most about, but methane, nitrous oxide, and other greenhouse gases, it's kind of like putting another blanket on. So it traps more and absorbs more of that outgoing long wave long wave radiation from the Earth and radiates it back down to the surface. So we're very familiar with greenhouse gases and their effect. The one that's most common is water vapor. And so we know that when it's humid and when we have clouds in the sky, it doesn't cool off as much at night. And that's a factor of the greenhouse effect. This is a graph that shows fluctuations and then changes in carbon dioxide concentration going back basically about 1 million years. And you can see that current carbon dioxide concentrations are far in excess of what they have been in Earth's history. And so that's considered to be a real driver of our changing climate. Again, it's like putting some extra blankets on. But what the implications of that are is, you know, it's not easy to determine and assess because the atmosphere is a fluid. It moves, circulates just like the oceans do, and both the oceans and atmosphere move energy from the sun and transform it around the globe in very complex ways. Now for us in kind of the Mid-South area, what I would say, when we think about climate, we need to consider what the drivers are. What are the things that kind of affect and cause our climate to be the way it is? And this diagram kind of highlights 3 key things. One is the notion that we're not really close to the coast. You know, we're not as far away from it as some areas, like the Dakotas and such, but we're not close to the coast. So we have an influence of the continental effect, the land mass. And so land areas tend to heat up fast in the summer and cool down very quickly in the wintertime. So they lead to very extreme conditions in terms of summer heat and winter cold, as opposed to being on the coast where the oceans change temperature much more slowly and climate is much more moderate. We're also influenced by the our position relative to the Gulf of Mexico. That's our main source of moisture, and especially in this time of year, we have the advection of warm, moist air that comes from the Gulf of Mexico, brings us that uncomfortable summertime humidity and a lot of rainfall associated with thunderstorms that develop in this time of year. And then the third part is the storm track that steers the jet stream that steers weather through our region, and that storm track moves depending on the time of year. So that jet stream tends to separate the warm, moist air to the south from the cool, dry air to the north. And right now we've got 2 or 3 really nice days where the jet stream has dipped a bit and we're having air coming out of the north. But that won't last for long until we're back to the warm, moist air from the south. Again, in the summer, that jet stream tends to push to our north, and in the winter, it comes down, becomes very active and a big influence on our weather. So I said climate change is a wicked problem. And when we talk about a problem, then that implies a problem is a condition that we don't consider satisfactory. We want to do something about it. Implies that some actions are necessary. But climate change has been a difficult problem for us to tackle for a variety of reasons. And here are some characteristics of wicked problems and some other examples here on the left of others where they have a wicked element. So the problem has no clear formulation. If somebody said, well, what is the problem of climate change? If we had everybody sit down and write a definition, we'd come up with a lot of different definitions. There are competing explanations as to, well, what's causing the problem? And again, within the scientific community, there's lots of research being done and lots of different theories about what factors are really the key drivers in climate change. And we've learned a lot. There's not as much debate about that as there used to be, but still it's pretty complicated. The quality of solutions are shaped by people's perspective in terms of, well, what is it that you're trying to achieve in addressing the problem of climate change? In some parts of the world, societies might benefit from a changing climate. In other parts of the world, it would be very devastating to see climate change occur. So how we address it depends on who you are, what your perspective is. Trial and error approaches are risky. You can't really just play games with it and say, well, let's try this and see if it works. Because if it doesn't work or goes the wrong direction, you might not be able to recover and do a tremendous amount of damage. And science alone is not the solution. It's a social issue, it's a political issue, it has religious tones to it and such. And if you think about it, those same kinds of issues make the healthcare problem difficult. Poverty, we haven't been able to eliminate poverty. These are all kind of wicked problems by nature. So in terms of climate change, it's a wicked problem because of all the complexities related to the science and technology, the economic implications of climate change. It's become, unfortunately, a polarizing issue where you have stakeholders at different political points of view and such that make it difficult to get people to collaborate toward a solution. And again, it's hard to define and assess, what solutions would be really desirable. And then on top of that, our human beings, our minds are impacted by all sorts of cognitive biases that make us very inefficient at processing information and being objective when it comes to solving problems. So I'd like to get ready to go to a breakout and talk about some of these things here in just a moment. But before I do that, I want to really cast this as a really critical problem. So climate change is important because it has all of these components, impacts, environmental impacts, it affects migration, it affects the economy, it affects geopolitics, and on and on. Effectively, it represents a change in the distribution of natural resources. And climate change, if you didn't believe it was really a problem, a quote from Larry Fink, the CEO of BlackRock, the world's, I believe, the largest investment banking firm and such in the world, basically sent out a letter to shareholders a couple years and said, we need to essentially pay attention to global finance because it's going to change because it has not up to that point really factored in the effects of climate change. So if people that manage billions and trillions of dollars are concerned about it, must be a problem. Okay, so to prepare you for the breakout session, when I was a youngster, my dad grew up in West Virginia, up in the hills, and loved to hunt. And when I was young, he'd take me out deer hunting with him. And one thing I learned was that if you're going to go deer hunting, it would help to know what a deer looks like, so that you know what you're hunting for and recognize it. Same thing when it comes to climate change. How would you recognize climate change if you saw it? So with that, I guess we'll pass it back here, and we're ready for a breakout session to address a couple questions here. What arguments do others make in an effort to convince you that our climate is or is not changing? And what compelling evidence have you seen that convinces you that our climate in Kentucky and Tennessee is changing, if any? So I'll send it back to our organizers and take a few minutes, not more than 10, and then we'll come back and delve into Kentucky and Tennessee's climate. All right. Well, let's move forward, and I think we need to move fairly quickly now. I hope you had an engaging conversation and maybe didn't have answers for everything. So I wanted to first give you a real quick background. We're going to talk about a lot of climate data, and we might question where some of that data came from. So now we're looking at observational data that has been collected for going back over 100 years, well over 100 years in some cases, by different groups within or affiliated with the federal government and or state governments, using a variety of different types of equipment, including now much more automated types of sensors for monitoring the climate. So here's just to kind of whet the appetite a little bit, no pun intended here, a list of the 10 wettest years on record. And this is going back to 1895 for Kentucky and for Tennessee. And I've highlighted there on both those lists the years that occurred within the last decade. So if you're trying to recognize whether the climate's changing or not, first of all, it's not a simple yes or no answer. It's a matter of compiling evidence that would be enough to convince someone in the court of public opinion whether the climate's changing. So again, in both cases, we've had 5 of the 10 wettest years. That's 5 of the 10 wettest years in over 125 years of record that have happened in just the last 10 years. So what's the odds of that happening if the climate is not changing? And here's likewise looking at the 10 warmest years on record. And in both cases, 4 out of the 10, or 40% of the warmest years on record, have occurred within the within the last 10 years, which represents less than 10% of the historical record. So both of those are heavily weighted, if you will, towards recent years. So now I'm going to show you a set of graphs, and I want to explain what you're looking at so you can interpret those graphs a little bit. These are based on Kentucky, and I apologize to those from Tennessee, but we're looking at scatter plots that show time on the horizontal axis. So you're looking at years dating back to 1895, and actually made these in the middle of 2020. So some of the years don't have the completion of 2020 on here. But each dot represents a year. And on the vertical axis here, you can see this is showing precipitation. So it's the average statewide precipitation for a given year. And then there's a line that kind of winds its way as sort of a cyan colored line. That is a line that tracks the average through time. It's a smoothing curve. And then you see some rectangles, some darker shaded, and then they're surrounded on the extremes by lighter shading. So The darker shaded rectangles represent each decade, and they enclose the middle 6 or middle majority of the years within that decade. And then the lighter shaded years are shown on the bottom. The 2 wettest years of the decade are highlighted in the lighter shaded triangle, and the two driest years on the lower end, the 2 wettest years on the upper end. So it's different ways of looking at precipitation trends. If you look at this graph, you can see that the trend line shows that the average precipitation in the first half of the 1900s was somewhere a little bit above 45, maybe 46 inches, kind of averaging through that period. Now, again, each year, if you look at the actual dots, they fluctuate quite a bit above and below that line, but the line is sort of in the middle of all that. But as you move forward into the last few decades, that line trends upward rather sharply, and now is at a level that is over 50 inches, approaching 55 inches. So that's a pretty significant change in terms of precipitation. You can also see that I circled in yellow some three different areas. If you look at that first circle of 3 years in the 1950s, at that time, those 3 years that were circled represented the first time that three of the five wettest years on record had occurred just within a short period of time, within a decade, and that happened in the 1950s. And then again, things dried off a little bit, or dried out, but then we came back in the 1970s, and again, we did that. We had 3 out of the 5 wettest years on record in the 1970s. And then again, in the last decade, we broke that record again. 3 of the 5 wettest years now have occurred within just the last 10 years. So while precipitation amounts fluctuate up and down, really no matter how you look at that, it suggests that we're getting wetter and that really dry years are becoming much less frequent than they used to be. From my perspective, that's an indication that our climate is changing. And we can see the same things if we look at precipitation on a seasonal basis. So what we're looking at here is the same type of graph, but we have a series of 12 of them. If you look at the upper left, that graph has a label at the top, DJF, that represents December, January, and February. So that's a December, January, February. Essentially, that's winter averaged together, 3 months. And then the next one is January, February, March. So there's an overlapping 3-month window. We dropped off December, we added March, and on throughout that. So we effectively are moving a window throughout the seasons of the year to see whether that increase in precipitation is occurring just at certain times of the year, whether the pattern might be fundamentally different depending on the summer or winter, or whatever the case might be. Let the data speak. What does the data tell us? And if we look at this, you can see with the smoothing curves, first of all, there's a tremendous amount of variability in the amount of precipitation that we get in any given season from year to year. And so it would be difficult just by memory to have any sense of whether the climate was changing. But if you look at the smoothing curve, you can see that they're all trending upward. And especially in the spring months, the ones that are highlighted with the yellow stars there, April, May, June, July, really show up with a trend line and also with the dark shaded rectangles. It's getting wetter in the spring at the early part of our growing season before we even get into the summer months. But it's really getting wetter, a little bit wetter in all times of the year. So this is important to remember. Our climate's getting wetter, and especially in the spring. What about temperature? Temperature trends are a little more complicated. They look like a roller coaster for our region. We had very warm temperatures in the first half of the 1900s. 1921 is our warmest year on record. And then we went through a cool period where temperatures cooled down. There was talk of going into an ice age back in the 60s and 70s. But since then, temperatures have rebounded. And while 1921 is still the warmest year on record, Again, 4 of the 10 warmest years have occurred in the last decade. And if you look at the trend line there, it is now higher than it ever was back in the first part of the 1900s. So the average annual temperature has become clearly warmer than it was in the past, to where we're basically a little over 1 degree warmer. And again, there's no way a person would feel that if you're looking at the temperature averaged over a whole year and say, gee, it feels about 1 degree warmer over the whole year than it did a long time ago. No one could tell that just by feel, but if you look at the data, let the data speak. What does it have to tell us? Now, one thing I'll say, and I don't want to spend much time on this, but an ironic, well, I don't know, ironic's not the right word, but an interesting feature is that if you look at our temperature record for the US, there's something called a warming hole that is kind of located over our part of the country. And basically it's saying that in the Southeast and parts of the Midwest, this is an area that while other areas have gotten noticeably warmer, we haven't. In fact, for a while we were getting cooler. And there's been some research done to try to understand this and some different ideas about why it's happening. Again, I'm not here at this time to go into that, other than to say the data show that that's what has happened in our area. So it makes climate change less evident where we are compared to what can be seen in other parts of the country and other parts of the world per se. Now, if we go back and look at those trends for maximum temperature. So these are seasonal trends, but now we're looking at the average daily maximum temperatures by season. And by now you look at the smoothing curves and you can see that same sort of roller coaster pattern showing up in different areas to where we've been getting warmer now for quite a while, but in some areas we may be warmer than we were in the early 1900s. But if you look across the middle tier of graphs there that get us from the spring in through the heat of summer, you'll note that if you look closely, the smoothing curves do not exceed the peak levels that they reached in the first half of the 1900s. We're getting warmer, but we're not nearly as warm as we used to be. And if you look at some of the individual dots for individual years, you can see that the highest ones are all back in the 1920s, 30s, in that period compared to today. Here, we're looking at the average low temperatures. And here the picture is in some ways similar. You see some of that roller coaster effect, especially in the winter months where there's much more variability of our temperatures than what you see in the summer. Take note of that. Look at the graph in the upper left and the one in the bottom right and those times. Look how much variability there is in the point pattern up and down from year to year. And then look in that tier across the middle for the warm season of the year and how much more tightly packed those points are. Our weather does not fluctuate as much in the summer as it does in the winter because we don't have the jet stream fluctuating through our region in the summertime. But the other thing I want to point out here is that in that center tier, as we get into the summer months, if you look at the smoothing curve, you'll see that the average low temperatures in the summer months have exceeded well beyond what they were in the first half of the 1900s. So our low temperatures are at record highs, but our high temperatures are not in the summertime. That's interesting and perhaps somewhat perplexing until we take a look at this next graph. This graph shows a relationship between temperature and precipitation. And while you may not have studied this from a scientific perspective, you actually know more about it than you might think. So this is looking at the diurnal temperature range. The diurnal temperature range is the difference between the average high and the average low temperature on a daily basis. So that's diurnal temperature range on the vertical axis, and on the horizontal axis is precipitation. Look at the, again, the middle tier of graphs. You can see that the scatter plots there show a very distinctive downward trend. And so what that says, there's a negative relationship. So it says that as the amount of precipitation that we get in a given season increases, the diurnal temperature range decreases. So the difference between the highs and lows decrease. Now that's important because if we look at what happens when we get into a drought, when it's really dry, droughts tend to come with heat waves because as the surface dries out and there's not much moisture in the environment, more of the sun's radiation goes into heating, sensible heating of the environment, including our bodies. Whereas when it's very wet, a significant portion of that energy from the sun goes into evaporating moisture and into the transpiration of plants, which we don't feel as sensible heat. So there's a scientific basis to explain why as we get wetter, our temperatures may not go up as much, but it certainly feels more humid. And so we have more of those very muggy, unpleasant nights. Now, let's shift gears though from extreme weather, or talk about extreme weather events in a changing climate. And this came up in our breakout session. So just because our climate's changing doesn't mean extreme events don't happen. And a great example of that was this spring where we had a snowfall, and here's a picture of it, on April 21st. We don't expect snow in Kentucky in April, even though the latest snow was on May 20th in 1894. But it happened, and it's a weather event. There are some arguments and some theories that suggest that this type of event could actually become more common in some ways as the climate changes. But again, that's a little bit beyond the scope of what we can get into with the time we have today. What I'd like to make as a point though, is that whether the climate's changing or not, and more importantly, even if it changes, we're still going to have heavy snow events. We're still going to have ice storms. We're still going to have cold waves and so forth. They're just not going to happen as often. And that's what this next slide kind of highlights. It's that bell-shaped curve, the so-called normal distribution, that shows that in a changing climate, that curve or distribution of our weather, our temperatures and precipitation is expected to slide and change and shift. And when that does, it doesn't mean that these extreme events don't happen anymore. It just changes the likelihood or frequency with they happen. So it would mean that winters with heavy snow that stays on the ground for 2 weeks, they still might happen, but they're going to be much less frequent. On the other hand, heat waves that in the past were maybe less frequent should happen more frequently. Maybe not with the super high temperatures as much as the super high humidity and discomfort in terms of the heat index. Now, I'd like to go back and think about, what are the implications of climate change? What should we be looking for and focused on from a practical point of view? And just go back over the last decade, and there was a period there that from May 2010, where we had, and I've got some slides here, we had extreme precipitation and flooding. And then later that year in October, we had drought. And then the next spring in May of 2011, we had flooding again. And then the next year in 2012, we had a really bad drought. And so within the context of a changing climate, we can have all these fluctuations of types of weather events. So the May 2010 flood, many of you remember this, although it depends on what part of the region you're in, because it didn't affect everyone equally. But May 2010, here in Bowling Green where we are, we missed the brunt of it, but we still had plenty. We had 10 inches of rain in 36 hours, significant flooding on the upper left there. You see a picture of the Barron River flowing past downtown Bowling Green on the left in normal or lower flow conditions, and in the right in flood stage with that event. And on the right side, you get pictures from Nashville, which was really in the bullseye of this event, where they had recorded precipitation of almost 14 inches in 36 hours. Some areas radar indications of precip totals up to 17 inches or so in that region. So the concern is that in a changing climate, these things could happen more frequently. The atmosphere holds more moisture. The Gulf of Mexico waters are warmer. There's more moisture that can advect into the region. 2011, May of 2011, I saw something that I never thought I would see. And I looked at some of our participants, where folks are from. This is on the lower right are pictures of Rough River Reservoir here in Kentucky. And the picture in the middle is a picture of water flowing through the spillway of that reservoir. I never thought I would ever see water actually flow through one of the spillways at any of our Army Corps projects, but it happened on more than one of those reservoirs during that event. Here in Kentucky, in some areas, we had from April into the first week of May, about 5 weeks, we had over 20 inches of rain in some areas. And on the left side, you can see satellite imagery of the flooding on the lower Ohio River and Mississippi River from western Kentucky down into Tennessee. And in the lower image, you see what it would look like under more normal conditions the year before that. Now, 2012, talk about flooding. Now let's go back to drought. And again, this was just the next year. We had a very significant drought here in the United States, and it developed a core area of it was in western Kentucky and western Tennessee, and that drought intensified rapidly in our region and started to spread across the country. To give you an idea, here at in Graves County, down around Mayfield, we have a Mesonet station that recorded over 3 inches of rain on March 8th. And then over the next 3 months, the entire spring season, it only reported 4.4 inches, probably about 10 inches below normal. Meanwhile, at the end of June and into early July, over a period of 10, 11 days, the average high temperature, not on one day, the average temperature for that entire period was over 99 degrees. It baked the crops. The corn was devastated by that unless you had irrigation and a good bit of it in that area. And this is a graph that shows something called the Evaporative Demand Drought Index. It basically shows how thirsty the atmosphere is, how much it wants to take water out of the environment. And you can see the very widespread, intense colors that basically saying the atmosphere was extremely hot and extremely dry, and it wanted every drop of water that it could find to evaporate or transpire. Unfortunately, there was very little water available. And this slide kind of shows, you see a dome of high pressure in the middle with storms wrapped around it. That was sort of the area in the middle over Kansas, Nebraska, Iowa, Missouri. That was the core of that drought-stricken area. We were fortunate though, because later in the year, that drought, basically we got relief. That the drought moved to our west. We started to get rain coming back in the summertime and into the fall, which is normally our time when we're most vulnerable to drought. But it didn't happen. We got away with it. Otherwise, we might have been looking at a 1930 type of drought, our drought of record, where we set our all-time high temperature and had huge precipitation deficits across the state and region. Okay. I'd like to close up here just briefly by focusing on something called flash drought. That's a term you may not have heard of before, but like a flash flood that we're familiar with, it comes on very quickly. A flash drought is the equivalent. It's something that develops very quickly. And flash droughts are expected to become more common in the future. And so in 2016, you probably remember this event. It was particularly troublesome in eastern Kentucky and eastern Tennessee in the southeast, where after a relatively wet year, when we got into October, November, it became very dry, and it was also extremely warm. The graph on the left shows for the history of climate data in Kentucky. Horizontal axis is average temperature, vertical axis is total precipitation, and it's for the September, October, November period. You can see 2016 highlighted there as the second warmest and one of the driest, though not the driest. It was very unusual, and it came on very quickly after the summer had been a very wet summer. And then again in 2019, we had, in some ways, an even more phenomenal event where it had been a wet year, a very wet year, one of the wettest on record. But when we got to September, the rain stopped. The average rainfall for the month was about 0.2 of an inch across the whole state. Bowling Green and Louisville had 22 days in September with temperatures reaching 90 degrees or above. September was actually the hottest month of the year. So really phenomenal that year. So those types of events are expected to become more frequent. So to summarize, our climate in Kentucky and Tennessee is becoming wetter and it's becoming warmer. During summer, hot days and warm, humid nights are likely to become more frequent as we move forward. Winters display tremendously high variability compared to the summer, and they're likely to become milder. In fact, it's been about 50 years since we've had a really severe winter. But we'll still have snow and such, but the periods where we have a snow that lasts and stays on the ground for a long time expected to become much shorter duration, much less frequent. And we expect to see greater extremes of stream flow on the Ohio River and its tributaries that will be associated with both an increased risk of flooding and an increased risk of drought. So with that, I will pass it back to you, and hopefully you have a better sense of being able to recognize climate change when you see it.
Well, fantastic. Thank you very much, Dr. Foster, for that. I think I speak for everybody when I say it was a great way to kick off our conference and dig deep into science. And I think now we're in the right frame of mind to get into the rest of the week. So that was fantastic. Thank you once again.